Hello and welcome, everyone. My name is Mark Henry. I'm a senior engineer with Augmantic's North American office located in Charlotte, North Carolina. Today, we're going to be talking about performance and fault management for managed service providers and enterprise class businesses. We do have a fairly full webinar today. So just for a bit of housekeeping for everyone, we're putting everyone on mute by default during the presentation. We are going to be recording the presentation during the main presentation itself. However, we're going to give you guys the opportunities to come up with any Q&A questions at the end. So what we'll do is when we're done the presentation, we'll turn off the recording, unmute everyone, and you can ask any questions you have. Also, please feel free to use GoToWebinar's chat. Raise your hand, ask any questions you might have. We'll keep an eye on that as well during the presentation. I've also provided a copy of this PowerPoint in the handouts section, so you should be able to grab that from the GoToWebinar interface and download a copy of that if you want it. So topics for today. We're covering 4 pieces. Some of them are kind of business theory, and then some of them are going to be practical application and how to, right? So we're going to talk a bit about packaging performance and fault monitoring as a service. We're going to talk about handling overlapping IP addresses and multi-tenancy, which is a requirement of pretty much any managed service provider or enterprise class business. We're going to talk about leveraging trending data to intelligently adjust fault management, so you can get away from kind of static thresholding and alerting. And we're also going to talk about how to create focused, purpose-driven dashboards by client and task for your end users. So we're going to talk about how to use an end user portal. So just briefly, a little bit about myself. I've got 20 years experience as a network engineer, but also as a software developer. During that time frame, I've started, built, bought, and sold my own managed service providers, mostly small regional outfits focused on the SMB marketplace. That's where I've gotten my experience, and also that's where I discovered Augmantic's tool sets, fell in love with them, and ended up coming here and joining the Augmantic team and working here with Augmantic and helping educate people throughout North America on the options that are available to them. Today, we're going to touch on 4 main Augmantic solutions. That's going to be NMIS, which is Augmantic's core performance and fault monitoring solution. OPHA, which supports horizontal and vertical scalability. OP Charts, which is a customer portal or can be a customer portal and provide customized dashboards to end users. And we're going to touch on OP Trend, which provides predictive trend and analytics. So at a very high level, what I'd like to present to you is the concept of an example scaled server architecture. So what many of you are used to now might be the deployment of agents out into the field at your client sites, at remote sites that reside on servers, whether they're Windows only or Windows and Linux. They gather performance information and then push them back up to one or more collection points. Augmantic's network monitoring solutions take a different bend. Instead of deploying agents, which require you to know what devices you have out in the field, we actually take the perspective of polling devices using a combination of SNMP, SNMP traps, syslogs, WMI, NetFlow, IPFix analysis, and even CLI commands for configuration compliance work. So we reach out to the devices, pull information back from them, analyze that information, apply business rules to it, and then make determinations on what to do with the information that we've collected. One of the ways of kind of expanding in implementation is the process of rolling out multiple polling servers. So the concept of collectors out in the field, they might be collectors at your at department locations, they might be at remote geographic locations, they might be at client sites. Those pollers then report back up to one or more master servers, so at a secondary higher layer. We'll come back and we'll touch on this again a little later in the presentation when we talk about multi-tenancy and pull this piece in. I just wanted to prime you with this concept of kind of a multi-tiered scaled architecture. A little bit more granular, we'll step into the concept that at the polar level, polars are handling communication to devices or subnets, and then reporting metadata up to master servers. And again, they can be one or more master servers, and a master server may actually be designated as a client portal. So let's talk about the base concept here, the focus on the entire presentation. It's been my experience, both as an engineer consuming services from outside entities, also as an engineer and owner of a managed service provider selling services out into the enterprise size business space, and also now as an engineer working for Augmentech, helping to deploy and configure monitoring solutions for enterprises and service provider customers. In so many cases, end user clients are very much used to a break fix mentality. The concept that someone somewhere is going to have to pick up a phone and call and say, I can't get to my shared drive. My email box is full. I'm having difficulty running an application. It doesn't seem to work, or it's working very slowly. I have bad VoIP quality on my GoToMeeting calls. They have to pick up a phone, call some help desk, lodge a complaint, and that someone on the other end at that help desk or at a higher level engineering tier will then respond to that. In many cases, we view that as a break fix. It's very much a passive or responsive rather than proactive direction of engineering. One of the things we really try to advocate for here at Augmentech with all of our solutions, and that I've advocated for throughout my career, is the concept that it's much more important to be very proactive. And in order to do that, as an IT, whether it's a system administrator, a network engineer, someone who's in charge of user experience or application monitoring, in order to be able to deliver a proactive service, you have to be able to understand what your customers really care about. And at the end of the day, that's user satisfaction, not equipment state. Most customers don't care if a switch is up or down. Their true focus is really on understanding the user experience for their end users and ensuring that that any outages are not impacting their bottom line. Are they still able to do all of their own ROI internally? So to start out with, one of the things that we advocate is the concept of separating out the requirements for remote management, and that's usually remote desktop patching, and in many cases antivirus rollout, from performance and fault monitoring. So we separate those kinds of key points. There are many products on the marketplace now, both free and paid, for remote desktop solutions. Most operating system vendors, Microsoft, Red Hat, etc., offer different schemes for patching. There are also third-party applications, both in the open source and the paid marketplace, for patching non-operating system software. And when it comes to antivirus, you can go directly to your antivirus provider of choice and get a central dashboard, system rollout, etc. So we separate those pieces out from performance and fault monitoring. And the reason we do that is so many of the vendors that are out in the field now, when they try to roll too many things, too many features into one product, you end up with something that is very, very wide in features, but not extremely deep in functionality. So once you've kind of mentally done that separation, and you start thinking about what your lines of business or what your internal departments or even what your external clients are looking for, and you really understand that what they want and what they need you to monitor is user satisfaction, then you can start focusing in on the concepts of network and application performance and user experience. So the concept of how well are my applications performing? Can the users reach that remote website? Can they get to Microsoft 365? If the business is licensing a third-party SaaS solution, can they log into it? Can they execute transactions on that. So it's not just is the internet interface up or down, it's also is the end SaaS solution responding or not. So it's being able to execute synthetic transactions, log into some kind of an application, run whatever tests or queries, exercise whatever abilities of that application you can, and then track that information over time. So once you've come down to that concept that that's the service that you want to be able to offer, the next step is actually clearly defining a list of services that you'll sell. And again, whether that's internally to internal departments or externally to, if you're operating as a managed service provider, how will you sell those services externally? Coming up with a list of services, coming up with SLAs. So for example, bronze, silver, gold. What's your response times? How will you staff that? What are your costs and overheads? And then how do you sell those services downstream to the client? A recent survey came out just at the end of 2017, asking small and medium-sized businesses what services they were looking for. 48% of all SMBs that responded to that survey came back and said that they were working with some kind of a managed service provider. Almost all of them were trying to move more towards a consultative relationship with that MSP rather than a break-fix relationship. And that's an important thing to bring by. The concept that the more consultative you can be, the more you can actually provide that support for that user satisfaction as opposed to just equipment state, the more satisfied your customer will be with you. And also the higher the margins for your service can become. So once you've got your services, you've identified your services, you've defined your SLAs, the selling point really for the client is to help them understand really that these changes, this offering is going to help improve your reaction time. So rather than having to wait on someone at the client site to pick up the phone and call and say something's broken, you'll see it, you'll know it ahead of time. That will help you reduce your time to resolution. And more importantly, if you're really watching trending, how well the client's network or that line of business's network is performing, you'll be able to predict outages. So you'll be able to see things like disks trending towards full. You'll see things like temperatures running high on devices or within abnormal ranges, high uses of CPU, high uses of memory, high interface bandwidth utilizations, or high numbers of errors and emissions on interfaces as well. So all of these types of things can be trended, can be predicted, and will help drive your engineers to provide additional services back to that client again. So rather than responding and saying, you're having a crummy user experience on this application because you have too many people running on that server, you'll be able to go to the client and say, we need to make plans to upgrade this server in the next few months because you're running high on memory usage, because you're running high on CPU usage, and it's happening at certain times a day, and it's happening because of these types of applications that are running. So it becomes, again, very much more consultative relationship with your client. This next piece is how do you price that? We often hear questions, how do I price this? What do I offer this as? How does this compare to the marketplace? One of the key things that I've done personally, having owned managed service providers, having done my own pricing within my market, obviously I look to see what the market will bear. I look at what my competitors within the marketplace offer as far as services go. I understand the value of the product that I'm offering, and more importantly, I tie my pricing directly to the value. So a question I ask every client is, what's your cost of 1 hour of lost network time? If your internal network went down at 10 a.m. in the morning on a Monday and didn't come back to 11 a.m., what's your potential lost time? And it can be very important to understand that and then try to tie back in the value of what you're selling back to their ROI. So for example, we were talking to a large regional wireless gigabit broadband provider the other day and asked them, in lost SLAs, what does an hour cost you? and they came back and they said it costs about $50,000. If we're down for an hour, we're going to have to refund every commercial customer we have for an hour of time. It's going to be about $50,000 for an hour. And so the response was, okay, so if our solution, if we can monitor all of your equipment, we can report back, we can keep track of user satisfaction, user experience, application performance, and help reduce your outages. Every hour we save you gains you an extra $50,000. And that conversation then blossomed into, over the last calendar year, how many total hours of outage did you have? And adding that up and just being able to compare that and say, our solutions cost X dollars. That's 1/3, 1/5, 1/10 of what you lost last year due to outages. And then that gives a very powerful ROI conversation for you. The last piece, in many cases, clients can be hesitant to buy into performance and fault monitoring. They may perceive it as costly. They may perceive it as unnecessary. Many customers will say, when everything is running right, I have to pay you. That seems like wasted money. So you have to kind of be able to come back and demonstrate to them the value of that. And in many cases, what I'll do is actually implement performance and fault monitoring for a client, and then come in and talk to them and say, let's do this for a week. We'll do it free of charge. We'll monitor, a chunk of your network. We'll set you up with a portal access so you can log in, you can kind of self-correct and see what's happening along your network. And what we'll do is we'll touch base with you every week. We'll have meetings with you, and we'll go over what's happening on your network and what we're doing, and what you might want to look into investing in the future for hardware and equipment. Right? So you can actually give away a product in order to upsell them into a much more valued service. So now that you've convinced yourself that you want to be able to offer performance and fault monitoring as a service as part of your managed service offerings, again, either internally or externally, the concept is, how do you do it? How do you do it effectively, right? And right off the bat, there are two key components that you have to consider, no matter what solution you select ultimately. And those two key pieces are overlapping IP addresses and multi-tenancy, right? So no matter how you hash it, at some point you're going to end up with, whether it's two internal customers, companies are growing every day through M&A activity. We were doing some work with a financial institution just last month where they had purchased several bank branches, and each of those bank branches just had very, very simple LANs configured, running on 192.168 at each location. And so that just within branches within that acquisition, they had a lot of overlapping IP addresses. And so you have to take into consideration the concept that at some point you're going to have to handle overlapping IP addresses, and also going to want to deliver multi-tenancy, the concept that you can provide logical firewalls in between client data to prevent the exposure of confidential information to other tenants. So right off the bat, Augmantic's NMIS product provides direct support for overlapping IP addresses and also native support for multi-tenancy, right? So if you use NMIS by itself, we approach overlapping IP addresses by also allowing you to use fully qualified domain names in addition to or in replacement for IP addresses. And so right off the bat, if you have good network architecture and they're using fully qualified domain names, then you can easily use those in place of IP addresses and not have to worry. The DNS server will take care of all of that kind of resolution for you behind the scenes, and you can continue monitoring those devices with no problem at all. In addition to that, when you're starting to look at the concept of logical firewalls and multi-tenancy, NMIS has the concept of what internally we call tables, but really at the end of the day, they're metadata tags, and we ship with about a dozen different ones predefined, but you can define your own. So you might define things like customer, department, SLA. You can have location. You can have response time. You could have technician names, all that kind of stuff. But the big part of that really is coming down to the concept of customer and department, and being able to segment and organize devices and group devices into those types of metadata tags. So you might consider them the concept of a Venn diagram where you have overlapping circles. So you might have a customer and a department and even device types, for example, or responsible parties. And where those circles overlap is the area where that individual customer now has access and can view into. The final piece to take into this puzzle is the concept of scaling using OPHA to deploy multiple polling servers. So I kind of front-loaded those diagrams of Augmantic solutions earlier to be able to prime you for this kind of this part of the conversation. The idea that you can scale out by deploying multiple collection servers. For a large MSP, we have several now, North America, Central and South America, even along the African continent, with thousands of customers who are deploying hundreds of collection servers. They're doing it via scripting. They're using things like Ansible, Chef, Puppet, etc., to be able to deploy a virtual machine into the client atmosphere, add devices to that device, add users to that device, connect that polling server back to the master server array. And it's all something that can be done with just building out an Excel spreadsheet, filling in some fields, running whatever your automation software is, and again, Ansible, Puppet, Chef come to mind, and then deploying your devices and getting pieces set up and wired back into your master servers. So that gives you quick deployment. But what it also does is each of those polling servers, of course, can handle their own ranges of overlapping IP addresses. They also provide kind of logical firewalls because they're disconnected from each other, from every other polling server. And because they're only providing metadata back to the master servers, you can start at the master server for your NOC and then drill down into that device and go from a 50,000 foot view all the way down to an individual device on an individual polling server very, very quickly. The end piece to all this is the concept that, again, NMIS is going to handle overlapping IP addresses and multi-tenancy natively. It is a key piece that you must consider in selecting any solution that you go for. I'm just going to minimize my PowerPoint for the moment. Let's take a look at NMIS very quickly. So any of you who've downloaded the product, we're up to release 8.6.2G at this point. NMIS is Augmantic's free and open source network monitoring solution. And if you remember the diagram with our all of our modules on it, NMIS is the core piece of it. So when you start looking at licensing things like OPHA, OP charts, our event management system, OP events, or our configuration compliance solution, OP config, they all plug in just like spokes on a wheel into that central NMIS core. And I'm just going to drill down into an individual group. So I have groups here on this display, and you can see that I have a breakdown of devices. I've got a switch that's reachable. I've got looks like a server that's doing well, and I've got a small server here that's degraded. I'm going to drill into this server that's marked as degraded, and we can scroll down and see why it's degraded here on the left-hand side. So you can see it's degraded for high memory usage. All of these charts and graphs that you see are interactive. You can drill into any of these. And I can zoom in by clicking on the top part of the graph, zoom out by clicking on the bottom, right and left moves me left and right, etc. And of course, I have additional information that's available here from all my interfaces that I'm collecting, data on those interfaces, all my performance information here. All right. Before we get into OP trend, let me talk for just a moment about thresholding in NMIS. So thresholding or alert tuning is a concept of setting trip lines, for example, on when you will generate alerts, how you will generate alerts, who will those alerts go to, and what are those alerts for. So for example, at the top of this window, you'll see, for example, we have an alert set up for proactive disk queue length. And we have a total of 5 different alert levels. So we have warning, minor, major, critical, and fatal. They are listed in alphabetical order, although fatal and critical are swapped as far as the order that they are evaluated in. So by necessity, these types of thresholds are fixed points in space. So they can be assigned by class of device. They can be assigned by the event, so the name of the event, in this case, average disk queue length. They can be assigned by make, model, even usage of the device. So you might have a specific threshold for a Cisco Nexus 7700 that is assigned as a core device. And then you can set up a series of values for that. You might have sets of values for interfaces based on interface speed. So you might look at different speeds of interfaces, whether it's a 10, 100, or 1 gig, 10 gig interface, and deal with them differently. You might deal with disk space, for example, on a percentage basis or on a number of bytes basis, depending on how you want to look at it and how large your disks are. So a lot of flexibility here, but still at the end of the day, NMIS's built-in thresholding system is a fixed point in time. A key contributor, a key piece that we like to talk about with our clients is the concept of moving away from those fixed or static thresholds. And again, this is something that becomes an upsell to your end client, whether they're internal departments or external customers. The concept that you're not going to set a static alarm or alert for that customer that your NOC team needs to respond to. Instead, what you can do is you can trend that customer's equipment. You can look at that customer's equipment as its own individual piece, and then determine what is normal. So for example, we've all seen the concept of a customer sticks a switch or a router in a closet. There's no air conditioning. People stack stuff on top of it. It ends up on a hot day, the AC goes down, and the device runs hot, right? Well, that's an outlier, right? But if that device always runs hot, if it's always running warm, you don't necessarily want an alarm going off all the time, because what ends up happening is engineers start ignoring things that are repetitive. Anything that they see that they're not supposed to respond to, they end up saying, "Oh, that's normal. That always runs hot." With OP Trend instead, OP Trend tracks information. It takes and gathers 26 weeks worth of data. It looks at information one day at a time. So for example, you gather 26 weeks of data. It looks at every Monday and compares every Monday together. And then it looks at every hour on each of those Mondays. So Monday from 9 to 10 for 26 weeks, it will look and see what is normal for every single parameter that's being calculated by OP Trend. And OP Trend will look at CPU usage. It'll look at memory usage. It'll look at bandwidth. It'll look at the number of processes that are running. It'll look at every interface, both in and out. It'll look at the percentage used, the bytes per second. It'll look at all of your errors and discards as well for that 1 hour window on every day of the week for 26 weeks. And so what you end up coming up with is, rather than using static numbers, OP Trend creates what we call a billboard. So this is the billboard on the left-hand side, and you can see that this one guy is running a little high on CPU load. You can see it's at the number 1 position on the billboard, so the top 40 chart, go us. It's moved up 1 position in the past week. You can see that, for example, this Vienna server's moved down 2 positions. And then by clicking View SEDS, we end up with the display on the right-hand side. Now, the display on the right-hand side, you'll notice the blue lines at the top and the bottom. So, for example, this guy and this one. that provides you the window of normalcy for that time frame. The black line in the middle that's trending up and down, that's actually what occurred. So the blue lines are what is expected behavior. So something should be working within that window. Anything that outlies that window is a problem. So for example, this piece here that's up here in the purple, this guy up here, and each of these little spikes. Each of these are transgressions for what's considered normal for that time period on that device and this parameter. Now, importantly, as an example, each of these three outliers that I'm highlighting now, each of those three outliers happen at the same time of day over 3 days. If that continues, OP trend will adjust these blue lines and add a spike for that time of day to account for these outages. These may be backups occurring. It might be data transfer. Might be some internal process on this network that's taxing this server. But those three pieces will eventually, through the trending system, end up being normalized and understood. Until that happens, when these exceed the blue line, they'll raise events, and then someone in the NOC can then respond to those events. So again, the importance of trending is the concept that the system will understand what is normal for the client's location on a device-by-device basis. Not class of device, not manufacturer, not model of device, but the actual device that's implemented. What is normal for that device on a specific day of the week, a specific hour of the day, and then raise alerts based on changes in what's normal. So if you always do, or your client always does, a backup at midnight, and that's normal, and the system expects a backup to happen, but a backup doesn't happen, you can actually raise an alert for no data going through. So why does this become important? Well, if you're selling the concept of being a proactive consultant, as you're having conversations with your customer downstream, working on trying to educate them, trying to bring them on board as a customer, trying to move them from a break-fix standpoint to proactive monitoring with performance and fault management, and be able to help trend their usage, and again, help them plan for future investments by gathering trending and performance information. Not only are you telling them things that are broken using the standard thresholding system based on industry standards or manufacturer standards, but you can tell them what's heading into, bad spaces. You're using 95% of your RAID array on your primary Exchange server. Based on current usage and trending over the last couple of weeks, are going to be out of space in 9 days. We need to plan on expanding that RAID array, right? So gathering information gives you the opportunity, the information you need to have those kinds of mature engineering conversations with your customer, and again, gives you the opportunity to upsell them into additional services that you might offer, improvements in their hardware, and further ties you in and makes you kind of a sticky vendor with them. It also becomes a differentiator for you as well when your client might be out in the marketplace looking at options. Just very quickly, this is that same table that we just looked at, that same screen, and I can zoom into this. And see exactly what's happening over time. You can see again this purple area are what are called the EV plot bands. These are the areas that are outside or deviate, and you can see these blue lines that come in here are what is the expected standard deviation, and this is actually 3 standard deviations from the mean, which is the green line that runs to the middle. So for those of you who are kind of mathematical statistics heads, we're using a 26-week SEDS calculation to drive the underlying OP trend analysis system. All right, the last concept I want to touch on today is the concept of providing kind of a focused, targeted portal for your customers to use. This can be a very lucrative upsell to your end user clients. Again, whether that's an internal client or an external client. On internal clients, just the ability to provide your end user with a portal they can log into, see series of custom dashboards, business intelligence about their applications, about their section of the network, about the devices that they have, about whatever events that are running, and see that will help reduce your overall interruptions. Calls into the help desk for, hey, my internet is slow, it's crackly, what's going on, what's happening? They can come in, they might be able to see errors and drop packets from their internet service provider. You might map out the SLA for their ISPs and help provide that kind of information to them. You might provide a weather overlay, and we'll show an example of that later, with various geographic locations on it, so the client can go, oh, I can see now there's a heavy storm coming over the city. I can understand why that remote location has dropped offline. And that'll help cut down client interruptions. But more importantly, it gives the client a feeling of control and transparency over their account with you, right? In many cases, I've actually offered customer portals just as a service differentiator with no additional cost built in. I make it just part of the rolled in services for the opportunity. What that does for you, and also does for your client, when they're comparing you against other competitors in the regional market, they can say, oh, I get this from you, which I can't get from anyone else, or if I could get it, it's a huge additional cost. Because we don't necessarily use canned dashboards for our customer portals, while we do have them, we really recommend custom dashboards for your clients. Again, differentiator. A lot of the other solutions that you'll see in the marketplace, they only offer a handful of pre-built dashboards, and that's what you have to offer. That's what you have to go with. So some important things, right? Generally speaking, if you're going to use OP Charts as a customer portal, you're probably using OPHA. You're scaling out horizontally and vertically. So you're going to offer an OP Charts, what we call a portal server, just to your external clients. If you're dealing with clients that are outside your network, of course, you'd expose that through the internet, through a reverse proxy. If you're doing it into internal clients only, you wouldn't necessarily have to go that route. If you wanted to, you could do it on your intranet. Client accounts are created within OP Charts. This can be scripted. So we've had many of our clients who are, especially in internet service providers, who have created connections between their CRM, their client management solution. So as customer service adds a new client, as the deployment team goes out and installs, on-premise equipment, wireless routers, whatever, they turn on and they create new accounts inside OP Charts for that customer, generate emails welcoming them in with login information. The customer can control their own login, their own password resets, all of that kind of stuff. All of these things can be scripted. You can then provide custom dashboards, maps, charts, and even business services for that customer. So depending on whether you're an MSP, an internet service provider, or just an enterprise business looking to provide services downstream to your customer, again, a lot of flexibility, a lot of automation that's allowed in here. So you can deal with very large deployments if you want to, or you can do it manually and really customize the experience for each individual customer. And finally, because you have that fine-grained control, whether you script it or whether you build the experience individually, the customer can only see the elements you give them access to. And that's really important. And you can actually get that all the way down to an individual interface. So for example, if you're an ISP, you might have a central wireless transmitter on the top of a building. Each client within your location have their own on-prem equipment, or CPE, client premise equipment. And so you might give your client access to all of their CPE information, but only the one interface on the router, on the main router, that connects their CPE equipment. So they see both ends of that leg. You might also provide them with something from your core backbone. Totally up to you how you do it, how much information you give out. Let's take a look at what that looks like. So I'm actually logged in to OP Charts as an administrator. A lot of different ways that we can see information, from table views to panel view lists of devices. And of course, we can build custom dashboards. There we go. And this one just happens to be an application dashboard. So you can see I have a topological map across the top of the screen, talking about devices and interfaces from different levels. So this is the value chain for this application. I've got service status down here at the bottom, or in the middle left rather, where I can see that my status is up and I'm actually running synthetic transactions on an application and seeing what my load time is through the database. Down at the bottom here, I've got internet traffic through several different circuits. I've got these all stacked here. And then down the right-hand side, I've got various monitored services that I'm looking at. So pieces of equipment, monitored services, interfaces, and specific individual devices. Of course, you can build this out however you want to. So I'm just going to log out now. So I have access, as you can see through the menu at the top. I have access through many different products, many different views. Again, I'm logged in as an administrator. And if I log out, next I'm going to log in as a customer. So again, this is a customer user account name that you would provide out. That login screen, by the way, can be customized. Messages can be changed on it. You can apply your own CSS. You could even embed that login screen into your own internet template if you wanted to. So now I've logged in. I only have access to a total number of 4 devices. My menus have changed dramatically. I have access to this nodes view, and I have access to the maps view, and I actually have access only to 1 map. If I had more maps, I'd get a nice list. Here we go. US weather southeast. And I just built a simple 1-pane weather overlay with some data on a couple of different locations. So we have our Tampa branch, our Charlotte headquarters, our US data center, and the interfaces that are in between. Again, this was just an example of what can be done, not the limit of what can be done. So we have clients now who are scripting the deployment of polling servers, connecting them back into master servers, adding user accounts dynamically to the polling to the portal server, adding lists of access for devices, even creating complex dashboards by scripting. We have a couple of great blog entries that have just come out this month on the augmantic.com website that help direct you towards that. We'll be having a few more coming out in February that will expand on that concept as well. So make sure you check out augmantic.com for more information and some blog entries that'll kind of fill out these ideas and concepts that we've presented today. So that concludes our presentation for today. What I'm going to do next, I'm going to turn off recording.